5 and 3 over some number multiplied by another number and 1/2 is equal to 19. Solve for the two numbers. Here's an equivalent way of stating the problem. Suppose the two numbers are equal to m and n. We can rewrite the multiplication in the following fashion. We want 3 over m to be a fraction in lowest terms, and we want n to be a whole number that's greater than or equal to 1. So the challenge is to solve for the values of m and n. I thank Ramesh for this suggestion. Pause the video if you'd like to give this problem a try, and when you're ready, keep watching to learn how to solve this problem. I will present one solution that uses algebra and another solution that uses inequalities. Let's get started with algebra. Let's start with this form of the problem. We will use a trick of rewriting each term in this product. Let's rewrite the first term in this product. 5 is equal to 5m over m. Thus, the first term can be rewritten as 5m plus 3 all over m. Now let's rewrite the second term in this product. n is equal to 2n over 2, which means the second term in the product is equal to 2n plus 1 all over 2. Since we are multiplying these fractions, the denominator becomes 2 multiplied by m. We can then multiply both sides by 2 multiplied by m. From here, we will use a bit of number theory. Since n is a whole number that's greater than or equal to 1, 2n plus 1 is an odd number. That means 5m plus 3 must be an even number, and it must have a factor of 2. Furthermore, 3 over m is a fraction in lowest terms, so m cannot be a multiple of 3. This means that m does not divide 5m plus 3. Then, because 3 is a prime number, m and 5m plus 3 are relatively prime. This means there are two possible cases for 5m plus 3. One case is that 5m plus 3 could be equal to 2. But in that case, m would be equal to -1/5. And this is a problem because we know that 3 over m is a fraction in lowest terms, so m has to be a whole number that's greater than or equal to 2. So we can exclude this possibility. So the other possibility is that 5m plus 3 is equal to 2 multiplied by 19. This is equal to 38, which means that m is equal to 7. If m is equal to 7, we can substitute in, and since 5m plus 3 is equal to 38, we can see that 2n plus 1 must be equal to 7. This means that n is equal to 3. So we have one possibility. Let's go ahead and check it. We substitute in the values for m and n, and this in fact is a solution to the equation. 5 and 3 over 7 multiplied by 3.5 is equal to 19. So this is one way to solve the problem. But I want to go over another way that uses inequalities. I actually figured this out after I went through the algebra, but I think it's an easier way, or at least a quicker way, to solve the problem, so I wanted to present it. Let's focus on the term 5 and 3 over m. Notice that it's between 5 and 6. Also, all of these numbers are positive. So if we take the reciprocal of each term, we will flip the inequality sign. We can then multiply each term by 19. The upper bound is 19 over 5, which is equal to 3.8. The lower bound is 19 over 6, which is equal to 3 1/6. This means 19 divided by 5 and 3 over m must be something that has a whole number part that's equal to 3. This means that n is equal to 3, so we've immediately solved for the value of n. From here, we can substitute in. We then take 19 divided by 3 1/2. This is equal to 19 divided by 7/2, which is equal to 38/7, which is equal to 5 3/7. Thus, m is exactly equal to 7. And we've immediately solved the problem using inequalities. We get the solution that m is equal to 7 and n is equal to 3.